In the last 3 years, I have watched more smart truck buyers skip the dealership entirely and head straight to private sellers looking for pre-2005 trucks. They are not broke, they are not naive. They have done the math and they have decided, quietly, without fanfare, that the best truck they can buy is one that is 20 years old. Here is why they are right. My name is Wade Tucker. I have been turning wrenches on pickup trucks since 1984. I spent 22 years as a diesel mechanic for a logging company outside Knoxville. I retired early in 2015, and I started this channel because I got tired of watching good people get sold trucks that were designed to cost them money instead of making them money. If you own a pickup truck or you are thinking about buying one, what I am about to tell you is going to save you tens of thousands of dollars over the course of your driving life. There is a segment of truck buyers right now, mostly men and women between 30 and 55, mostly in trades, farming, construction, ranch work, who have figured out that a 20-year-old pickup truck is the most honest machine you can own. Some of them have the money to buy whatever they want. They choose the old truck because they know what the old truck gives them that the new truck takes away. I want you to subscribe to this channel because I am going to give you knowledge that nobody at a dealership is going to give you. Nobody at the manufacturer is going to sit down next to you and explain why they stopped building the truck you actually need and started building the truck that makes them the most money. I am going to do that. That is what this channel is for. Now let us talk about the trucks you should be looking at. The specific model years I am about to give you are not guesses. I have personally owned, driven, or torn down every single one of them. First, the 1997 through 2004 Toyota Tacoma, specifically the models with the 2.7-liter four-cylinder and the 3.4-liter V6. Those engines are the 2TR-FE and the 5VZ-FE. Both of them are absolute gems. I have seen a 2000 Tacoma with the 3.4-liter hit 380,000 miles with nothing but regular oil changes and basic maintenance. These trucks have a fully boxed frame, which is something you do not see anymore. The body panels are steel, not aluminum. When something wears out, you can find a replacement at a junkyard for $30 and install it in your driveway with basic hand tools. Second, the 1995 through 2004 Toyota Tundra. First generation Tundra with the 4.7-liter V8, the 2UZ-FE engine. This is the same engine that Toyota used in the LX470 and the Land Cruiser. It was built to survive off-road expeditions in places where the nearest dealer is 300 miles away. The 2UZ-FE has iron block, aluminum heads, and a design philosophy that prioritized longevity over cost cutting. I have seen these engines go well over 400,000 miles with proper maintenance. Third, the 2001 through 2006 Chevrolet Silverado 1500, specifically the LS trim with the 4.8-liter or the 5.3-liter, the LM7 or the LH6 engines. These are the Vortec 5300 engines, known among mechanics for being some of the most workable engines General Motors has ever produced. You can change the oil without a lift. You can replace the starter in a parking lot. These trucks have a steel full-size frame that is actually capable of carrying a real load. The 5.3-liter has been proven to handle 300,000 miles and beyond with basic maintenance. Fourth, the 1997 through 2003 Ford F-150 with the 4.6-liter 2-valve V8. This is the modular V8 in its first and best configuration. No 3-valve gimmicks, no cam phaser problems yet, no AFM cylinder deactivation nonsense. The 4.62V is a workhorse engine that Ford used in everything from police interceptors to light-duty trucks. The 4-speed automatic behind it is the 4R70W, a tough transmission built to handle the torque without falling apart. Now I want to explain why these specific years matter. This is not sentiment, this is engineering and policy. The year 2005 matters because that is when the tire pressure monitoring system mandate came in. TPMS requires a sensor in each tire that talks to the truck's computer. Every wheel well on a modern truck now has an extra electronic component that will eventually fail, requires special tools to diagnose, and costs $50 to $100 per sensor to replace. On a truck with 4 sensors, you are looking at $200 to $400 every time those batteries die. On an old truck, none of that exists. You check your tire pressure with a gauge. It costs $3. It works every time. 2005 is also right around when a lot of the aluminum era began creeping in. Ford started using aluminum for engine blocks in some applications. General Motors moved toward more composite materials. What it also meant was that when your engine overheats, you now had an aluminum block that could crack in ways a cast iron block never would. I've seen 2006 and 2007 engines with aluminum blocks that were done at 120,000 miles because of a cracked block after a thermostat failure. A cast iron block from 1999 does not crack the same way. You can overheat a 1999 4.6 two-valve and it will usually survive. The other thing that happened around 2004 through 2006 is that the full steel frame started disappearing. Manufacturers started building trucks with unitized construction and composite body panels that looked like steel but were not steel. A steel fender on a 2000 Silverado will rust, yes, but you can see the rust. You can treat it. You can replace it for $30 at a junkyard. A composite panel that is rotting from the inside looks fine until it falls apart. I want to talk about something else that matters enormously and that nobody at a dealership will ever bring up: repairability. I have watched trucks go from machines that any competent mechanic could diagnose with basic hand tools to machines that require dealer-level proprietary software just to read the error codes. The modern pickup truck has somewhere between 40 and 100 control modules, depending on the model. Every single one of these computers can fail, and every single one requires software updates, calibration, or programming that only the dealer can perform. I have had trucks come into shops where the customer was told they needed a new transmission, $2,000 or more, when the actual problem was a faulty sensor that cost $37. And the reason the shop could not see that is because the sensor was throwing a code that looked like a transmission fault to the generic scan tool. Only the dealer-level software could see the full picture. On a 2001 Silverado with the 5.3 liter, you can hook up a basic code reader, a $90 one from an auto parts store, and you can read every code the truck generates. You can clear it yourself. You can look up the meaning on free forums. You can order the specific part and replace it yourself. Now let us talk about money, because this is the part that matters most when you are deciding what to buy. A 2001 Toyota Tacoma with the 3.4 liter V6 and around 150,000 miles. You can find one right now for between $8,000 and $15,000, depending on condition and location. That is a truck you can drive for another 150,000 miles with basic maintenance. You are looking at maybe $800 a year in maintenance if you are doing the work yourself. Compare that to a 2025 full-size pickup truck. The transaction price is somewhere between $42,000 and $55,000. The average monthly payment on a new truck right now is around $750. Over a 5-year loan, you are paying $45,000 before you have paid a single dollar in maintenance, insurance, or fuel. The tires alone on a modern full-size pickup, because they are low-profile, large diameter, can cost $800 to $1,200 for a set of 4. The oil change at the dealership runs $120 to $160. The brake flush now requires a scan tool to reset the indicator. The reliability data on modern trucks is not as good as the reliability data on the pre-2005 trucks. I have been tracking this for years. Modern trucks are seeing higher rates of transmission failure in the first 100,000 miles than the trucks of the late 90s and early 2000s. They are seeing more fuel pump failures, more sensor failures, more ECM failures, more issues with emission systems that require dealer-level software to reset after a repair. Now let me tell you what breaks on an old truck and what it costs to fix it. On a Tacoma with the 3.4, the most common issues are the rear main seal. It tends to leak at high mileage, and the universal joints in the drive shaft, which create a vibration that is unmistakable once you have heard it. The rear main seal job on a Tacoma requires dropping the transmission crossmember, but it is absolutely something you can do in your driveway over a weekend. The U-joints are a 2-hour job with basic tools and cost about $35 in parts. On a Tundra with the 2UZ FE, the most common issues are the air injection pump valve and the ignition coils, which can start to misfire at around 150,000 miles. The coils are about $60 each, and you can replace them yourself in about 20 minutes per coil because Toyota put them on top of the valve cover where you can reach them. On a Silverado with the 5.3, the most common issue I see is the intake manifold gasket. They tend to develop leaks at around 100,000 miles, and the classic symptom is a coolant odor after a highway drive. The manifold costs about $200 for the aftermarket unit, and the labor to install it, if you are paying someone, is around $600. If you do it yourself, it is an afternoon. On an F-150 with the 4.62 valve, the most common issues are the idle air control valve, which gets carboned up and causes a rough idle, and the upstream oxygen sensors, which can drift and cause a rich condition. Both parts are under $50 and both are accessible without removing anything more than the intake tube. Now let me tell you what breaks on a modern truck and what it costs. Modern trucks with direct injection and high pressure fuel systems have fuel pumps that operate at pressures exceeding 2,000 psi. When those pumps fail, you are looking at a pump that costs between $800 and $1,400, plus labor that can run another $600 to $1,000. Total bill, $2,000 or more. Modern trucks have more sensors than ever, and sensors do fail. The MAF sensor fails and your truck runs rich and your catalytic converter goes out. These sensors individually are not expensive, often $50 to $120 each. But diagnosing which sensor is causing the problem requires either dealer-level software or a mechanic who charges you for the privilege of looking at the screen. The transmission failures on modern trucks are a different animal. The 8-speed and 10-speed automatics are sophisticated units, but they have more failure modes than the 4 speeds they replaced. When one of these modern transmissions has a problem, the diagnosis often requires the dealer's software, and the repair often requires transmission replacement that can run $5,000 to $10,000. ADAS, Advanced Driver Assistance Systems, is the thing nobody talks about when you buy a new truck, but it is going to cost you money eventually. Lane departure warning, automatic emergency braking, adaptive cruise control. All of these systems use cameras and radar sensors. When you get into a minor fender bender and the bumper cover needs to be repainted, the radar sensor behind the grille often needs recalibration. When the windshield gets cracked, the camera behind the rearview mirror needs recalibration. These recalibrations require dealer-level equipment and can cost between $300 and $800 per system. I want to talk about what you should do in the first 90 days after you buy a 20-year-old truck, because buying the right truck is only half the equation. Day 1 through day 7, do a complete fluid check. Engine oil, transmission fluid, coolant, brake fluid, power steering fluid, and differential fluid in both differentials if it is a 4-wheel drive. Smell the fluids. If the transmission fluid smells burnt, that tells you something. If the brake fluid is dark brown instead of light amber, that tells you the fluid has absorbed moisture and needs to be flushed. Week 2. Change the engine oil and filter. I do not care what the previous owner said about when it was last changed. You do not know how they drove it or what oil they used. Change it now with the right oil weight for your engine and your climate and put a quality filter on it. Week 3, inspect the brakes. Look at the pad thickness through the wheel spokes. Check the rotors for grooving. Check the brake lines for any signs of swelling or cracking. If the truck has been sitting, the rubber brake lines are often the first thing to show age. Replacing all 4 brake lines with steel braided lines costs around $300 and is some of the best money you can spend on an older truck. Week 4, check the suspension. Push down on each corner and release. More than 1 or 2 bounces means the shock absorbers are worn. Check the ball joints by grabbing the top and bottom of the tire and trying to rock it. Check the tie rod ends the same way. These are safety items and they are not expensive to replace. Week 5 through week 8. Address anything you found in the first 4 weeks. If the truck has over 100,000 miles and you do not know the history of the timing components, now is the time to decide whether you are going to replace the timing belt, water pump, and related components. On a Tacoma with the 3.4, the timing belt and water pump interval is every 90,000 miles. On a Tundra with the 2UZ FE, it is every 90,000 miles as well. If you do not know when this was last done, do it now. Week 9 and 10. Test the HVAC system, heater, air conditioner, all fan speeds. If the AC is weak, it is usually one of three things: low refrigerant, a failed compressor clutch, or a blend door issue. All three are fixable for under $500 in most cases. Week 11 and 12. Take it on a real load. Hook up a trailer if you have one. Drive it on the highway and see how it handles a sustained pull. Watch the temperature gauge. Listen to the transmission. If anything feels wrong under load, now is the time to address it, not when you are 200 miles from home on a dark road. That is the first 90 days. That is what taking care of a 20-year-old truck looks like. It is not complicated. It is just attention and basic maintenance and a willingness to learn how your own truck works. I want to tell you about my personal truck. I have owned a lot of trucks in my life, but the one I keep coming back to in my memory is the 1997 Ford F-150 with the 4.6-liter 2-valve V8. I bought that truck in 2003 for $4,200. It had 112,000 miles on it at the time. I drove that truck for 12 years. I changed the oil every 3,000 miles. I replaced the brakes, the shocks, the ball joints, the U-joints, the water pump, the thermostat, and the upstream oxygen sensors. I did all of it myself in my driveway. At 312,000 miles, the engine started using oil, a quart every 500 miles. I pulled the engine in my driveway over a Kentucky winter. I had the machine shop bore it and hone it, replace the rings, replace the valve guides, and do a complete valve job. Total cost for the rebuild, $1,800. I put another 80,000 miles on that engine before I sold it to a neighbor who still drives it today. I sold it for $3,100. Let me do the math for you. I paid $4,200 for the truck. I put roughly $2,000 into it over 12 years in maintenance and repairs. I sold it for $3,100. That truck cost me $3,200 over 12 years. That is $266 a year. That is less than the cost of 1 month of payments on a new truck. Now here is what the people who are buying 20-year-old trucks right now have figured out. They have figured out that the math on a new truck does not work unless you are the kind of driver who trades every 3 years and never does your own work and never looks at the bills. The trucks I have talked about today are not perfect. They have quirks. The Tacoma needs the rear main seal at high mileage. The Silverado needs the intake manifold gasket. The F-150 needs the idle air control valve cleaned. These are well-documented, well-understood maintenance items that any competent mechanic can address. And they are not expensive. They are not catastrophic. They are not mysterious. What they are is honest. These trucks were built to be worked on. They were built to last. And the best thing about them is that when something breaks, and something will break because that is what machines do, you can fix it yourself in your driveway with tools you can buy at any auto parts store, and you can be back on the road before dinner. That is why smart drivers are buying 20-year-old trucks and never going back to new. If this video made sense to you, subscribe. I have more videos on this channel where I break down specific trucks, specific repairs, and specific maintenance schedules. Everything on this channel is free, and everything on this channel is designed to help you keep your truck running without having to depend on a dealership to tell you what is wrong with it. What year is your truck? Tell me in the comments.